Okay, in this video, I'm going to go over this handout or this page. And what we're doing when we find a mixed strategy equilibrium is determining the probability that we want for C1 and C2, the probability that player 1 plays C1 and the probability that he plays C2, and then the same for R1 and R2, probability that player 1 plays R1 and the R2. So we'll call the probability of playing C1 P, and the probability of playing C2 1 minus P, and the probability of playing R1 Q, and the probability of playing R2 1 minus Q. Okay, and so then our goal is to find probabilities that make the row player 1 indifferent between R1 and R2, and probabilities that make the player 2, player 2, indifferent between C1 and C2. Okay, so the column player controls P and 1 minus P. He controls how often he's going to play C1 and how often he's going to play C2. And we want it to be the case that the expected utility of playing R1 and the expected utility of playing R2 are the same. Okay, so we set up the expected utility for each. We just care about these values. So the expected utility for R1 is going to be P times 2 and 1 minus P times 0. And for R2, it's going to be P times 0 and 1 minus P times 1. Okay, then we set them equal to each other. So this is 2 and 0, 0 and 1. Okay, then we just solve for P. So we have 2P, that's going to go to 0, equals, that will go to 0, and this will just be 1 minus P. So we'll add P to both sides. So 3P equals 1. Divide both sides by 3. And we find that P equals 1/3. Okay, so the idea is to make player 1 indifferent between playing R1 and R2. We want P to equal 1/3, or the player 2 wants P to equal 1/3, and 1 minus P then to equal 2/3. So player 1's strategy is going to be 1/3 C1 and 2/3 C2. Okay, now we do the same for these two expected utilities. So we have the probability of playing R1 as Q and the probability of playing R2 as 1 minus Q. So now we just care about these values. So the expected utility of playing C1 is going to be 1 times Q and 0 times 1 minus Q. And the probability of playing C2 is going to be 0 times Q and 2 times 1 minus Q. Okay, so then again, 1, 0, 0, and 2. So we have Q, that will go to 0. That goes to 0. 2 minus 2Q. Add 2Q to both sides. That gives us 3Q equals 2, or Q equals 2/3. Okay, so to make player 2 indifferent between playing C1 and C2, Q needs to equal 2/3, and 1 minus Q needs to equal 1/3. So player 1's strategy is 2/3 R1 1/3 R2. Okay, so then our mixed strategy Nash equilibrium is going to be just what we've said. Okay, there we go.